Hello and good day, everyone. Welcome to class. So, in today's cybersecurity analyst course, we'll be looking at networks and basically network communication. So, we are in the session for network, and we've talked about network a little bit in the first module. We just briefly described what network communication is when we're talking about securing networks and all of that. So this is time we'll go a little bit deeper into networks, the forms of transmission of networks, and basically understanding what networks is, because network is so important. If you want to be a cyber security analyst, you need to understand what a network is and how communication is done over a network. That's how you can be able to secure a network. So let's start off with, before we can understand network communication, we need to understand what network is in the first place. What is a computer network? So a computer network is a system, this is a very simple definition, a system that connects two or more computing devices so they can communicate and share resources. So we are looking at a system that connects two or more computing devices so they can communicate. So you see, the primary purpose is for them to communicate. Communication means they exchange data and they share resources, like files, like printers, internet access. They share files, they share internet access, or whatever it is. So that is a very basic definition of a computer network. Then if you are looking for a more standard definition, we can look at a computer network as a group of computers that is used that use a set of common communication over digital connected devices, with a protocol or a set of protocols for the purpose of sharing resources. So it's quite the same thing. What we're looking at is group of computers that are using set of communication over digital connected devices, and then they use protocols for the purpose of sharing resources. So in the basic sense, when you talk about a computer network, you're really looking at when you have one, two, three, or a group of computers that need to communicate with each other, that need to share resources with each other, that need to exchange data. So that means there could be a network between me and you, because I'm probably using a device to communicate to you, and you are the receiving end. You are also receiving this via a device. Networks are essential for organizations to communicate and connect. So important. So because of this communication essentiality, is very important. They are also protected because communication increases the risk of an attack, and also it provides all these threat actors and malicious actors with opportunities to exploit the vulnerabilities that exist in devices and unprotected networks. So it's very important that companies, organizations ensure that their network, their communication over network are secure, and data sent from one point to another point is typically secure. So communication occurs or involves the transfer of data from point A to point B, and these data are broken down into what we call packets. So like I said, communication is done from 2 points, a point A to point B. Then the communication is done via or broken down into pieces of what we call data packet. So, and that data packet is actually packaged and then sent with information about its origin, destination, and the message itself. So the best way to look at a data packet is to look at it like a physical email. And then, when you send an email to somebody, it actually leaves your direction, leaves where you are, and is pointing towards a direction. So it has its sense of origin, it also has its destination. So we're going to look at this a whole lot, looking at more about more terms that includes IP, media access control, and all of these terms as we move along. So it's very, very essential to understand how network communicates. Then basically we're moving straight into what we have in communication across network. Basically, there are basic models that are being used. There's a transmission and control protocol, which is called the TCP, and the internet protocol, the IP. So it's always used together, the TCP IP model. So this model is more of a standard model used for communication across networks. So I'm going to explain it a little bit so you can really have an understanding of what the TCP and the IP model is all about. In order to understand the TCP IP model, you really need to understand what a protocol is. It all starts with what a protocol is. So a protocol is simple, very simple, just set of rules that govern how networks communication is done across the network. So among devices, so devices agree on how data will be shared, how they're going to receive data, data will be moved, and all of that. So basically, in simple terms, when you ask what's a protocol, it's just the set of rules that are being agreed. So I like to put this in this way: a protocol officer, someone that stands and directs traffic. Oh, this is where you're going to move, this is where you're going to move. But even though it's directing traffic, you almost know where you're going to, right? That this is where it's going to move, right? Because there's a set of agreement between you, imaginary, and the protocol officer. Maybe through what do you call the name now? A board or whatever it is, or his hand that is directing. So there is a level of agreement that happens across network devices of how data will move. So that is really what the protocol is. It's very, very simple. Now, that's when we now have to come to what they call the TCP, that's the Transmission Control Protocol, or IP, Internet Protocol. So basically, there are two main models that are being used for communication across a network. So it's either they use the TCP IP model that consists of four layers, or the OSI model. So the OSI model, we're going to talk about that later. TCP IP model and OSI model are actually having so much similarities. So they're basically used for communication across a network. So let us start with the TCP IP model. We've talked about the fact that communication across the network is very important because at least data must move now from one point to another point across the network. So how does it happen? That's what we now have to discuss about the model of communication. So we've talked about the TCP IP that consists of four simple layers. So we will discuss these layers right away. The first layer we'll talk about now is the application layer. And this is the one that is so essential and dear to us. In the application layer, this is the layer that directly deals with the end user. So basically, this is layer that uses user applications like web browser and email client. This is the area that you interact directly with. So when you want to access a website, for example, you use a browser and you type the website, maybe link https maybe https://djtconcept.ng. So now you are using that one to request a web page from the server. So what you don't know is there's actually a connection going on, and there's a transfer protocol. A protocol is actually organizing and orchestrating that communication between the server and the application. So it's more like the website is also having a communication with your own media device. So that communication is actually done through the HTTP protocol, which is an example of what happens in the application layer. So other application layer protocols are maybe like email, the SMTP for email. So SMTP is more like simple mail transfer protocol. That's for email. So this is a protocol that is used to transfer emails. or the FTP, which is the file transfer protocol. So FTP, basically, if you've done a little bit of web development or software development, or even if not even too much, at least if you've done even able to work with cPanels before, you could have maybe worked with WordPress or something like that. You will see that when you're trying to move files from your maybe your device, your laptop, maybe to the server, you could use a FTP, file transfer protocol. So it helps you to transfer files directly from your system to the server. And if you've not done it, you'll probably still get used to it one of these days. Anyway, so it's not something difficult at all. So the application layer is one that takes the data from the application and prepares it for transmission down the other layers. So we're looking at the application layer at the top because that's the one that you as the end user interact with. Imagine that you want to actually request for a page on a server. So you are actually requesting for it. You tap the web browser, you are sending it to an address. So all that goes on, you don't even know, but there is a level of communication that is actually done through different layers of the TCP IP model. So the control protocol, transmission control protocol, and the IP protocol. There's layers that ensure that your request is given to you. So it all starts with the application layer. Then it now moves to the transport layer. The transport layer just ensures that there's a reliability of data delivery between applications. So the transport layer makes sure that it maintains data flow and also makes sure that it establishes connection between the sender and the receiver. So the transport layer is very important. Transport layer is has two main protocols. That's the TCP, transmission control protocol. And what it does is to make sure that there's reliable error check delivery of data. Data is sent without major errors or whatever it is, and it breaks the data into segments and numbers them, then reassembles them at the destination. So it also handles error detection like and transmission if segments are lost. So transport layer is very essential. It makes sure that what you send actually gets to the right destination. So it provides some protocols to ensure this. So what I'm trying to make you understand is if there has to be communication, it has to be done over a protocol. So like the transport layer, for it to work, it has to provide some protocols to make it happen. For example, the first layer, the application layer, for it to work, it also has to provide some protocols to make it happen. So if I am I'm trying to browse the server, I'm trying to check an application or browse. So I have to encounter an application layer, and for it to work, it has to present some protocols to make it happen. So protocols like HTTP to make it happen, protocols like SMTP to make it happen. Same thing, the transport layer now, it has to provide like protocols to make it happen. So it has to provide the TCP, the transmission control protocol to make it happen. Then the transmission control protocol, there's also another one called the UDP, that's the user datagram protocol. User datagram protocol is also very useful when identifying errors too, and takes during and identify errors and other tasks during the transmission of information. So user datagram protocol is actually very fast. It ensures that data is sent very fast, but it is not as reliable and it doesn't guarantee delivery in that order. So it's more for people that prioritize speed over reliability, maybe like streaming videos or online gaming. So that is when UDP is used. So both of them can be used, TCP and UDP. But TCP is more for reliable, ordered, error-checked delivery of data, whereas UDP is very fast but not as reliable as TCP. So let's backtrack a little bit. For communication to work, there has to be transmission across communication across protocols. Protocols has to be the one to make sure the communication actually work. So, like we said, the TCP/IP model is just used as a basic model to ensure communication. It starts with the application layer at the top, then it moves to the transport layer. So after the transport layer, now we can talk about the internet layer. The internet layer is responsible for routing data packets across network. So basically, when we talk about a packet, well, the simplest definition we can give to a packet is when communication is done over a network, there has to be a transfer of data from one point to another. This data is broken down into pieces called data packets. So I don't know if that is very simple for you to understand. When communication is done across a network, the transfer of data from one point to another must be broken down. If it's broken down into pieces, small pieces, those pieces of which the communication is done is called data packet. So data packet is more like a basic unit of information that is transmitted between devices over a network. So I'm transmitting something from device A laptop, to device B, maybe a palm top, like your device, like your phone or something like that. Now, the basic unit of information transmitted from device to device A to B, as I'm speaking to you now, I'm transmitting across the network. So the basic unit the basic piece of information I'm transmitting across the network is called a packet. So when the data is sent, it's packaged as a packet. All right, and the packet contains so many information. It contains information about its origin, its destination, and the message itself. So another way to look at it is to think of data packets like a physical email that needs an envelope with recipient address and return address. So it's very simple to understand. So basically, that's what the internet layer is all about. It's responsible for routing data packet across networks. So it sends data packet and routes it across a network. So that's where we now talk about the IP here, the IP protocol, Internet Protocol. So the IP protocol is the main protocol used in the internet layer. So I don't know if you've seen an IP before, but you might have seen it one way or the other. So IPs are more like these numbers that has to do with 192.168.1.1. So those are kind of IP addresses. So what internet layer does is that they route these IP addresses and forward packets to their destinations. So we'll still talk more about an IP address later, and then how IP addresses really work. So for you, internet layers, what they do is to route your data packet. After what the data packet is, basic unit of information that sends from one device to another device. So your data packet, how does it get routed across the network? So it is the internet layer that does this to route it across the network. So what IP does is that IP adds IP addresses to the data packets, so indicating the source and destination devices. So I don't know if you get that. What IP does is to add addresses. So they add a specific address because every device has its own specific IP address. It has its address. So IP will just add the IP address to the data packet so that it will indicate the source and destination devices, which is very, very crucial. Number four, on the last on this, is the network access layer. So let's talk about one more protocol that is used in the IP internet layer. Okay, so we said internet layer is responsible for sharing packets from the sender to the destination side, and also assigns a proper route for data destination or transmission. So we use the IP. Remember, IP, Internet Protocol, that is used to assign a unique address to a system. We also have the ARP. Okay, we also have the ARP. Okay, move on right away. Now let's move on to the last one. That is the network access layer. The network access layer, or or call it the link layer. So not data link. Data link is for OSI modem. So the link layer. So the network access layer, this is the layer that handles physical connection between devices on the same network. So what it does is responsible for smooth transmission of data and files between devices on the network. So when you want smooth transmission of data between devices on the network, then you should be thinking about the network access layer. So what I say again is it handles physical connection between devices on a network. So it's very easy to understand. It converts IP address into physical addresses or MAC addresses. So it also transmits data frames over physical medium. So this one is helping you to convert your IP address into your physical addresses, and it's very important to know. So just to do a recap, the TCP IP model is more like the application layer, the transport layer, the internet layer, and the network layer, or network access layer. So how does data flow really? Data flows starting from the application. So an application creates the data to be sent, then it moves to transport. The data is broken down into segments in TCP or datagrams UDP, and port numbers are added to them. So the next is the IP addresses are added to the packets to the internet layer. Then the network access layer, the packets are converted into frames and transmitted over a physical network. So this is how the TCP IP model works. So to make it so easy for you now, we'll just do a comparison with the OSI model. So the OSI model is comprising of about 7, instead of TCP IP that is comprising of just 4. So now what is the relationship now? In the TCP IP model, we have the application layer, whereas in the OSI model, three things we have in OSI model represent the application layer in the TCP IP model. In the OSI model, we have the application layer, presentation layer, and session layer. So those three is what represent application layer in the TCP IP model. In the and the major protocols used there are HTTP, SMTP, and File Transfer Protocol (FTP). In the transport layer under the OSI model is the same transport layer under the TCP/IP model. The next is the network layer under the OSI model is called the internet layer in the TCP/IP model, whereas the data link layer and physical layer in the OSI model is the network access layer in the TCP/IP model. So just to do a recap, I've said recap several times. So a recap now. Communication needs to be done across a network. But for communication to be effective, it has to be done with a communication model. So the basic communication model is either is OSI model or the TCP IP model. So it's called TCP IP. TCP IP model has 4 incredible layers. So the layers describe how communication flows across network, all beginning with the application layer. The application layer is the one that concerns the end user. You are going to interact with it. You are going to send a request and whatever. So it's going to provide protocols to assist you in making it to work. So from there, the transport is done that transfers these maintaining data flow and transfers across the layer, and also make sure that it gets to the right destination. It also makes sure that it's error free or reduces the level of error that can be across the network. Then it provides some suitable protocols in this, the transmission control protocol, or the UDP, user datagram protocol. He said UDP is very fast, but it's not as effective as TCP. TCP is more for error-free connection. UDP is just for speed. Speed is the major concern. Then we can talk about the internet layer that is responsible for sharing packets from the sender to the destination side. Then it assigns a peculiar route protocol, that's the IP protocol, or the ARP protocol, the address resolution protocol. Then it assigns a unique address to a system so that the system can identify. Yeah. Then the last one, the network access layer. This one is for smooth transmission of data and files between the devices and the network channel. This is the little we discuss about this. So if anyone got you scared, don't be scared. We'll still continue talking about it, and you need to understand this. We'll still continue talking about it, and then you get it. All right. Thank you for joining me in this class. Join me in the next class.